So what is supervised learning? Machine learning or statistical learning equivalent terms methods are categorized into two broad or main categories: unsupervised learning and supervised learning. There are other categories, but they are not major ones. Okay, there we have reinforcement learning, and also we have semi-supervised. But we don't focus on them. We won't review them. We won't go through them because unsupervised and supervised are enough for this, considering the scope of our module. So let me remove them. I just wanted to introduce you to the names and that the non-major categories. So supervised learning is one of the major categories of machine learning algorithms. Supervised learning is about learning the association. This is a very, very important term, and I will repeat it over and over and over again. Supervised learning is about learning the association between predictor variables and a target variable. So a data set, if this is a data set, there is one variable that can be considered as a target based on your problem, the problem that you want to address, and a set of variables like the ones that you see here. So this is target, and the other ones, they are predictors. Okay? You choose a set of variables as predictors. A supervised learning method or algorithm tries to understand, to discover, to learn the relationship between the target and the predictors. So try to learn this association or relation. A set of methods that try to discover how a set of predictors are related to a target variable. Having learned from a dataset, these algorithms or methods would be able to predict the value of the target variable for any new case. So we don't want them to learn this association for sake of learning the association, but we want them to learn this association in order to predict the target variable of new cases. Let's see it in an example. This example is part of a data set. This data set is about churn. So churn is a very important topic in business. Churning customers are the customers that they are leaving or they have left our business. And it is said that keeping current customers is more efficient than attracting and acquiring new clients and customers. So it's important for us, for any company, for any organization to keep its audience, to keep its clients. Okay? If we can predict whether someone is going to leave, whether a client is going to leave our organization, is going to abandon our organization, which I'm going to use this term from now. If we can predict whether someone is going to churn, then a client is going to churn, then we can intervene. We can suggest some promotions or policies to keep that client inside of the corporation, inside of the client pools. So we want to talk about supervised learning and definition of supervised learning. We have this target variable. I have marked it in a new different color. And you can see it's a categorical binary variable for the first case, for the first client. The first client is a female senior citizen, no, so not a senior citizen, having internet service DSL and monthly charges 29.85, and churn, no. So it is a cross-sectional data set. So on one point of time, let's say we gathered all the data from our customers, and some of them are still our customers, some of them are our ex-customers. We want to use supervised learning to learn the association between predictors, that here predictors are gender, senior citizen, internet service, and monthly charges. So these are predictors, and we want to find the relation between these predictors and the target, which is churn. So this is our target. We want to figure out that how gender, senior citizen, internet service, and monthly charges values are related to churn. So let's look at this row. This ex-client is a male, not a senior citizen, using DSL, and monthly charges 53.85, and churn is yes. So you might jump into conclusion by comparing these two and saying that, well, male and higher monthly charges might be related, might be associated to churn equal to yes, to actual churning. The thing is, we cannot conceive all these records and variables simultaneously to find the relation. Okay, and there are these computer algorithms that can do so for us. They are not substitute to our thinking. Still, we need to help them to get better results. But for the computational part, they are very, very more efficient than our brain. So now, once again, let me repeat it, that supervised learning, it's a learning of the relation between a set of predictors and a target variable, and it is called supervised learning because the learning is happening under supervision of the target variable. And we want to train our models, we want our models to learn such association. So when we have a new customer that the customer is male and senior citizen and DSL and let's say 25 monthly charges, we want the algorithm to predict the outcome, the target variable for us, based on the historical data. So we want our method to learn from historical data in order to be able to have educated guess, and not any educated guess, but accurate educated guesses for new cases. We know the gender of the new case. We know whether the person is a senior citizen or not. We know the service. We know the monthly charges. What we don't know is whether this person is going to churn in 2 weeks or a month or not. So I hope it is clear now that what supervised learning is, and in general what it tends to learn.